Hello, welcome to page 2. All right, so we are looking at our parallel and perpendicular again, like we finished up on the last page, just a little bit, okay? So this says, determine if AB and CD are parallel, perpendicular, or neither. So we're going to compare our slopes by doing this slope formula, y2 minus y1 over x2 minus x1. If we get the same number, they're parallel. If they're opposite and the reciprocal, it has to be both of those, then they'll be perpendicular. And if it's anything else, we will call them neither. Okay, so we're going to find the slope of AB. So we're going to call this x1, y1 and x2, y2. We're going to find the slope here, which is, the formula says y2 minus y1. So y2 is negative 12 minus y1, which is 3. And then x2 minus x1. So 2 minus negative 4. Okay. So I will type that into my handy dandy calculator. I'm going to put it in as a fraction. Negative 12, take away 3. And 2 take away negative 4, and that makes negative 5 over 2. Okay, so that's one of our answers. And we're going to do the same thing for CD. So this is going to be x1, y1, oops, x2, y2. I can't write. All right, so y2 is 1. y1 is 5, so 1 minus 5. And then we do the same thing on the bottom, 0 minus 10. So 1 minus 5, 0 minus 10. 2 over 5. All right, well, those are obviously not the same. So are they opposites, meaning one's positive and one's negative? Yes, they are opposites of each other. That does not make them perpendicular. They also have to be reciprocal. Are they flipped over of each other? 5 over 2 flips over to 2 over 5. So you say yes to both of these, so these are perpendicular lines. Okay. All right, so I'm going to do this one a little bit quicker. Okay, I'm not going to label x1, y1, x2, y2. You can go ahead and do that. So I'm going to do the same order. Y minus y, negative 15 minus 3, x minus x, 8 minus 2. Negative 15 minus 3 is negative 18 divided by 6. So this is negative 3. That's AB. And then for CD, so this is AB. So for CD, the slope is going to be 11 minus 2, negative 5 minus negative 2. Negative 5 minus negative 2. So 9 divided by negative 3 makes negative 3. What do you notice about those? They are the same. So if they are the same, these lines are, parallel. Okay, so number 20, y minus y, 6 minus 6, x minus x, negative 1 minus 5, makes 6 over 6 is 0. 0 divided by anything is still 0. And then the slope of the other one, y minus y, x minus x. This is something divided by 0, and when you divide by 0, you cannot do that. So that is undefined. And when we have a slope of 0 and undefined, those are perpendicular to each other because this is a horizontal line and this is a vertical line, and those will always be perpendicular. That's an E right there. Okay. Okay, that's the special case of perpendicular. Okay, anything else will be neither. All right, so we're going to switch over into our inverse converse stuff. These are counter examples. Okay, a counter example is an example that proves a statement false. So we want to tell if this is a true or false statement. If it's false, we want to give a counter example, which is like an example that says that statement is false. For example, if I say all teachers are female, well, not all teachers are female. Mr. Oropeza is a teacher. He's a guy. You know, Coach Reader, Mr. Brown, you know, any of them, there are lots of men that are also teachers, so any of those would be a counterexample. And the nice thing about counterexample is you only have to give one, and then you're done. You don't have to keep listing all of them, okay? So this says all multiples of 4 are also multiples of 8, okay? So this is the first part. So I'm going to look at the multiples of 4. 4, 8, 12, 16, 20, etc., right? So this statement says all of these multiples of 4 are also multiples of 8. So the multiples of 8 are 8, 8 times 2, 8 times 3, 8 times 4, etc. Right? So are all multiples of 4 also listed over here? Nope. Which one's missing? 12 is missing from this list, so false. 12 is not a multiple of 8. 12 is not. So technically you just have to say 12. It's just asking for the counterexample, but this is why it's not a multiple, because it's not a multiple of 8. Okay? All right, number 2, the base angles of an isosceles triangle are always congruent. So here's our isosceles triangle, like our Christmas tree, right? So these sides are the same, and when those sides are the same, these angles down here, the base are always the same as well. That is true every single time. The product of two perfect squares is always a perfect square. Product means multiply, so we're going to multiply two perfect squares. So like 4, which is 2 squared, 2 times 2, okay? We can multiply that, say, by 9, which is 3 by 3. So this is 2 squared times 3 squared. 4 times 9 is 36. Is that a perfect square? Can some number times itself make 36? Absolutely, that's true. Let's try one more. Let's do well, I'm trying to get not too big in numbers. Let's do 4 times 25. So that would be 2 squared times 5 squared. 4 times 25 makes 100. That's 10 squared. That looks like it works. Whenever you multiply two perfect squares, they are still perfect squares. Okay. Supplementary angles always comprised. That's bad grammar. Supplementary angles are always comprised of one obtuse and one acute every single time. So supplementary means they're going to add up to equal 180. In order to do that, do we have to have one big number, more than 90, right? Greater than 90, and one small number, less than 90. Oops, wrong way. Less than 90. Is that the only way we can get two numbers to equal 180? I say no. Because what if they were both 90? That would work, right? 90 plus 90 makes 180. That's not acute and obtuse. Those are both right angles. Okay, so that could be our counterexample. Okay. Don't stress over that. Hint, hint, wink, wink. It's okay. All right. So now we're going to write our inverse, converse, contrapositive. Okay, they give us a statement here. If a line is tangent to a circle, it is perpendicular to the radius. Interesting question. We haven't talked about that yet, but that's okay. All right, so this is our hypothesis. This is what we're starting with. A line is tangent to a circle. This is our conclusion. This is our then part. It is perpendicular to the radius. I'm going to switch to a pencil. As I write on my hand. Lovely. Okay. Conditional. P then Q. So if this stuff, a line is tangent to a circle, comma, then the Q part. It is perpendicular. I'm going to write perp to the radius. Okay. All right. I'm not going to worry about the truth value. Don't worry about that. Okay. So that's the conditional. That's our original statement. Let me zoom out just a little bit. All right. So the inverse is this little negative symbol, not P, not P, not Q. So we're going to take this first statement and we're going to make it negative by putting the word not in there or taking it away. Since it doesn't have it, we're going to put it in there. If a line is not tangent to a circle, okay, so all we did was we put the word not right after the verb. A line is not tangent, then it is not perpendicular to the radius. Okay. Converse are your shoes. We're going to switch the order. So we're going to go back to our original statement, which was right here. If a line is tangent to a circle, then it's perpendicular radius. And we're just going to take those two things and we're just going to flip them around. So it still starts with if, but we're going to start here. If it's perpendicular to the radius, if it is perpendicular to the radius, then the beginning part, a line is tangent to the circle. Okay. And if you wanted for good grammar, line is like your subject, so you could put that up here in place of it. If a line is perpendicular radius, then it is tangent to the circle. That's cool too. Okay. And the last one is contrapositive. We're going to do both. We're going to switch the order and make it negative. So we want the perpendicular to the radius at the front, but we want it to be negative. So if it is not perpendicular to the radius, then our line is not tangent. Okay. All right, y'all just be really careful on this, because these sentences, when they're written out as answer choices, A, B, C, D, these all kind of blur together and look the same. I know y'all don't love to read that much, and so you don't read them really carefully and you pick the wrong things. So just take your time, be careful. Okay, use your properties. All right, triangle stuff. This is a little bit more recent. Okay. Find the value of x. So we have an x here for this piece, we have an x here for this piece, and an x for this piece. Okay, and I can see when I colored them in that these are the three angles in our triangle, and they're going to always add up to equal 180. So we'll take all three of them. It doesn't matter what order you put them in. So this is the first angle, this is the second angle, and this is the third angle, and together those all add up to 180. And once you have that written, you can pick up your calculator. Okay, calculator, menu 3, 2, whatever the answer is. I don't know, I don't care. Find the value of x, we'd be done. Okay, number 2, if AC equals BC. AC is this piece right here on the left, BC is this piece on the right. Why would they tell us that? If we have two sides the same, this is now an isosceles triangle. Two sides the same, we also get two angles the same. And if we think of it like a Christmas tree, it would be upside down like this, right? So these two angles down here would be our base angles. So those two angles, A and B, are going to be equal. Angle A equals angle B. So that says 8x minus 40 equals 5x minus 1. Solve for x. X equals 13. Does it say find the value of x? No, it says find the measure of angle C. Well, the problem is angle C doesn't have any stuff in it, right? So, but I can find one of these. This has stuff in it, right? So I can put this 13 up here where the x is. So that's going to be 5 times 13 minus 1. 5 times 13 minus 1 makes 64. So this, I'm going to draw it separately right here. So this angle right here is 64. What about this angle over here? We said that these two angles were the same, right? So this is 64, this is going to be 64. Now how much is the other angle going to be in our triangle? What's a triangle add up to? 180. So far we have 64 and 64, which makes 128. How much is left to get us up to 180? 52. Okay, that's a couple steps. That's a cool question. I like that one. I hope I put that on the test. That's a really good question. Alright, number 3 says find the measure of PRQ. PRQ. Oh, that's this angle right here where there's no stuff. Oh, I'm going to have to figure something else out. Okay, so let's go with what they give us. They give us this angle out here. They give us this angle here and this angle here. Okay, so this angle here, this is on the exterior of our triangle. And the rule says the exterior angle equals the sum of the two interior angles that it's not touching. Okay, so these two angles over here are going to add up. This is what we did. We said these two add to equal that one on the outside. 8x plus 2 plus 10x minus 19 equals that one on the outside. So this is an interior. This is an interior and equals the exterior. Alright, while you're writing that down, I'm going to type that in to my calculator. 8x plus 2 plus 10x minus 19 equals 16x minus 7. X equals 5. Alright, x equals 5. So I actually see two different things that we could do. What I know is I know that these two angles right beside each other here, the angle we're trying to find and this one on the outside, these two together make a straight line. So these two are going to have to equal 180. The other option is if you just look at the three inside the triangle, you can find each of these and then add and subtract from 180 like we did on the last one. Okay, I'm going to do these two beside each other. So I'm going to do this. So I have this 16x minus 7, and then this is the angle we're trying to find. So here we're going to do 16 times 5 minus 7, which is 73. So this angle is 73. So how big is the one beside it? 180 minus 73, 107. Okay. All right. Triangle properties. Which sides make a triangle? Add the two smaller sides. Must be greater than the biggest side in order, and then it makes a triangle. So the two smallest sides here on the first one are 8 and 8. So 8 plus 8 makes 16. Is 16 bigger than 17? No. So that is not a triangle. What are the two smaller sides on the next one? 2 and 11. So 2 plus 11 makes 13. Is 13 bigger than the other side, 12? Yes. So that makes a triangle. Which one are the two smaller on 26 and 15? These two right here. So 6 plus 15 makes 21. Is 21 bigger than 20? Yes. And 19, 34, 15. So 19 and 15 are the two smaller ones. When you add those together, that makes 34. Is 34 bigger than 34? No. It does not say it can be equal. It says it has to be bigger. Okay. All right, two sides of a triangle measure 7, and 19. Write an inequality to represent the range. So this is going to be your answer. It's going to look like this. It's going to have these boxes here. Okay. So we're going to take the two numbers, 19 and 7, and we're going to add them, and we're going to subtract them to find those, the range of that third side. So that makes 26, and that makes 12. So our answer has to be somewhere between 12 and 26. Remember, the small number always goes over here on the left, and the big number always goes on the right. And this stuff in the middle here doesn't ever change. Okay. Number 8, in triangle DEF, DE is 18, EF is 5, DF is 19. Order the angles from least to greatest. So they don't tell us anything about the angles, they only tell us the sides. Okay, so the first thing is we're going to draw our picture. So label the corners, DEF, it doesn't matter which one goes where. Okay. DE is going to be 18, EF is 5, and DF is 19. Alright, so we want to order the angles from least to greatest. So what I see in this picture that's the least is this side right here. Okay? This side is the smallest. So the thing that formed this side and made it small was this angle over here. Angle D is the smallest. Okay? Because angle D opened up to make the ends or make the length of that side over there. So the bigger that side opens up, then the larger that angle is going to be. Okay, so the next biggest is the 18. This 18 was formed by angle F, which makes the 19 the biggest, and the side that made that 19 was angle E. Okay, small to large. Okay, so 9 is the backwards of that. They're giving us the angles. Problem is that there's no angle down here in angle T, so we got to do that first. Okay, so we're going to find angle T because a triangle adds up to equal, thank you, 180. So far we have 61 and 56, which makes 117. 180 take away 117 is 63. So there's no more question mark here. This is now 63. So we want the sides from little to big. So the thing that I see here that's the smallest is this 56, right? This angle is the smallest. So the side across from that, RT, is the smallest. Okay, this is going to be the smallest. And then the next one is the 61. So across from the 61 is ST. That's the middle, which makes the biggest 63. And across from the 63 is RS. And it doesn't matter if you put SR, RS, that order doesn't matter. Okay. Alright, last one on page 2. They tell us that these two triangles are congruent. So right here, that means they're exactly the same. So all the sides are going to match up, all the angles are going to match up. Okay, it says find the value. So we want to know how big PQ is. So PQ is this piece right here. Okay, and what we learned is that if we do this 1, 2, 3, 1, 2, 3, we can tell which parts go with PQ because of the way they're listed. So first and second is going to go with WX. So PQ is going to be the same as WX, and I look over here, WX is shown to be 7.7. YW is 3.1, 3.1, so that's going to be RP. What do we know about RP? RP is 15.4. So WY is going to be 15.4, which makes the other side 17. You can go through that same process if you want. Okay, then we have the angles. Okay, angle Y is the same as angle R, because those are both listed third. So R is 27. I'm going to put a 27 there where the Y is. Q is in the middle, so it's the same as angle X, which is 65. So Q gets a 65. And then the last one, W. W is the same as P. They tell us that's 88. If they didn't tell us that was 88, we could add these two together and subtract from 180, and we would get 88, because all of these three together have to equal up to 180, because they're the three angles in a triangle. Okay, end of page 2. Appreciate you. Thank you for doing this. You're going to do awesome on your test. Love you. Bye.